should say chapter 4 is all about fractions, and what we're going to be doing is just mimicking what we did in chapters 1 and 2. We're going to learn how to add, subtract, multiply, divide, and order of operations, all right? But now instead of with whole numbers, integers, it's fractions. And my job is to make you not hate them as much as you do right this second. So even if I don't get you to like them, I want you to not hate them as much, okay? So I love food and I love cookie cake. Does anybody eat cookie cakes from like Schnucks or whatever? Yeah. Oh my gosh, I would have a cookie cake any day over actual cake. So instead of referring to pizza and cutting them into slices, I will be talking about cookie cake quite a bit. So maybe I can even bring in a couple cookie cakes for us one day, okay? All right, so let's go ahead and look what's going on. 4.1 is a nice introduction. It's not too scary yet. We're not having to do a whole lot of math or anything. It's just making sure we know the basics of like what exactly is a fraction. Keep in mind, a fraction's actually division. And a lot of times it's smaller over bigger, so we can't actually do the division, okay? So the first thing is identifying numerators and denominators. Numerators are always the top numbers. And denominators are the bottom number. Okay? So anytime I mention, and I'm pretty lax, like a lot of times they'll say, let's look at the top, let's look at the bottom. Like I don't always use numerator and denominator, but I'll throw those terms in there every once in a while, so I just want to make sure you feel comfortable with them. All right? So on my math lab, your first couple problems will just be, what is the numerator? What is the denominator? Okay? So you're just going to be pulling the number from the top from the numerator, and then the denominator. You know how I remember the denominator? This is so stupid. I can't believe I'm telling you this. How I remember denominator is, doesn't denominator kind of look like demon?
Yes.
And where does demon live? Down below. So that's how I always remember. It's stupid cheesy, but that's how I remember it. So your numerator in this one's 11, and your denominator's 2. It does. Anything that, I mean, this stuff, people roll their eyes at me, and then later on in the semester, they're using the exact same analogies. So what's your numerator for number 2?
10y.
And 10y, and it's all of it, okay? So if you have a lot going on, all of the upstairs is your numerator. And then 17 for the denominator. Not too bad, right? Okay, we're getting our feet wet, guys. We got our toes in the water right now. Let's see if we can get our whole foot in the water. All right? So the next one is just making sure that visually we can tell what fractions are. So fractions are parts, they're chunks. So what you have to think of is this whole rectangle. Has anybody had a Sam's cookie cake?
Yes.
The double-decker, that's the best. Okay, so Sam's makes these big rectangular cookie cakes. So say we cut them into these slices. Those dark slices are what I ate. How much of the cookie cake did I eat? Well, you have to look at the whole cake as a whole, but how many slices you have total is always your denominator, okay? So your total is always on the bottom, that's your denominator. And the shaded is your numerator. All right? So I always start with the denominator first. How many slices did we cut this cookie cake into? 6. How many slices did I eat? 3. And you leave it at that. We don't know about reducing or simplifying yet, okay? So I ate 3 slices of the 6 slices of cookie cake. This is kind of the same idea. How many total circles do we have? 6. And how many of those circles are shaded? 1. Is that okay? So those are still kind of kiddish because they're just like generic examples. But where in real life can you see it? You can see it in nursing. You see it a lot in athletics and so forth, okay? So it's kind of hard because I know it was copied. It's not the best. What they're showing you is just consider this part of the syringe from where the tip stops, like connects to the tube, to where you put your fingers, the depressor. We have that as a whole, okay? So how many little, and we're not counting tick marks, guys. We're counting gaps. Does that make sense? So you're counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 gaps. Do you see that? It's not tick marks. It's how many sections do we have marked. So we have 10 sections marked because we're counting this gap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? But then we just go back and do the exact same thing and stop where this I don't know if it's injecting. I don't know if it's, let's just say it's kids like ibuprofen, okay? We have kids ibuprofen in here. So how much are we giving them? We're giving them 1, 2, 3, 4, 5, 6, 7. Does that look right? Yeah. So 7/10 of the syringe. If it had a unit there, do that.
How would you get 7?
Because I'm going from this tip, so 1, 2, 3, 4, 5, 6, 7 is where it ends.
Oh, okay.
You see that? We're going to the darker shade. It's kind of hard to see. And like I said, you're counting like those little distances.
Okay.
All right, the 6 is the same idea. We're counting the ruler. The entire 1 inch is a hole. So how many fractions of inches do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I think that's right. Like, isn't rulers cut into 16ths and 8ths and quarters? So we have 16ths of an inch. So if anybody's going into carpentry, or if anybody's dad or uncle, like my father-in-law is a big carpenter, he's always measuring stuff like that. So what part do we have? Well, we go back and just count the little gaps of that dark number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that what you got? 9/16 of an inch. Those that are somewhat comfortable with fractions, realize a 1/2 inch would be 8/16, and we're just a little bit past it. So that's why we're at that 9/16. You guys can all count. It's just hard when it's copied and it's not as easy to see. All right, are there any questions on 3, 4, 5, or 6? So now you guys get to be the artist, okay? So what we have to do here is we have to do exactly what they did here with something, okay? I am not very good at, as much as I love cookie cake, I'm not good at dividing cookie cakes into slices, so I just do rectangles, all right? So to show 2/3, I'm just going to draw a rectangle. I want you to be cool. I want cool pictures, okay? So here's our rectangle. How many slices do we need in it? It's always the bottom number. So we need how many slices? 3, so that means we need to cut it twice. Is that okay? And then how many do we need to shade? 2 of them. And like I said, this is where you guys have fun. I know math's not fun. Try to make it a cool pattern or dotted or whatever. I'm not fun, so I just kind of stripe it. There's my 2/3. Is that all right? This one's hard. I think dividing something into 11 slices is quite difficult, okay? So on number 8, guys, I'm going to make like a really skinny guy. And I'm going to divide it to the most equal 11 slices that I can, which means I'm going to have to do 10 tick marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then like that's 10. So I need to do another one. You have to add on if you can. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I got my 11. So if you have to add on or whatever, be creative. And then we need to shade how many of them? 7. 1, 2, 3, 4, 5, 6, 7. Is that okay? What's nice is on my math lab, guys, you won't have to do that. You'll just pick the correct drawing. It'll just be a matching on that point on your My Math Lab homework. All right, any questions on the front page? Not too horrible, right? So we're getting our ankles wet now. They're going to give us word problems, all right? So word problems in real life that deal with fractions. You can tell how updated these notes are. 8 planets, not 9, right? So of the 8 planets in our solar system, 5 are further from the sun than we are. So what they want us to do is write a fraction that represents the planets that are farther from the sun than Earth. Well, how many total planets are there? 8. And how many are further from the sun? 5. Notice they can give you that exact same information and switch it up on you. They can say how many are closer to the sun, and you would say 3. See how you just do the flip-flop? So if 5 are further, Earth and the others are 3. I think you have one like that on your worksheet where they'll give you how many guys, how many girls. So you have a total number, and then you have to pick which is going to be your numerator. All right. These get a little difficult, I think. What we have to do is we have to represent the shaded part of each figure group as both an improper fraction. So this is numerator is greater than denominator. Okay? So improper fraction, I feel like if you're older, we grew up learning that improper fractions were just wrong. Like should never have a bigger number on top. And now they've kind of turned it on us a little bit. They say, okay, actually a lot of math is better if you have an improper fraction. So improper fractions are not as bad as they once were given. And then a mixed number, guys, a mixed number is a whole number with a fraction part. So mixed number and an improper fraction are kind of two definitions there. I have a cheat sheet. I meant to bring it today. I'll bring it on Tuesday of everything we're going to do with fractions. And it's an example of each thing, okay? So that way, I know we haven't learned all of it yet. And as of Tuesday, we won't have learned all of it yet. But when you're working on your homework, when it says change it to improper fraction, it has an example of how to change it to improper fraction. So you won't be able to use it on the test, but I think if you practice with it, you'll kind of get it in your system. All right. So the first thing we have to look at is what's our denominator going to be? Our denominator is how many slices one whole is cut. So notice we have two whole things. We have this and this. Each of them are cut into how many slices? 3. So the denominator is actually 3, okay? So there's 3 here and there's 3 here. So our denominator is 3. So you look at it as a whole, just focus on one or the other and say, how many slices are there? There's 3. But of those slices, how many are shaded? 4 of them, because now we're going to look at it as a giant picture. We have 1, 2, 3, 4 slices. That's our improper fraction that they're looking at, okay? So even though we have 2 things going on, we're looking at it as 2 cookie cakes. Each of them are cut into thirds. So that's why 3 is the denominator, but we have 4/3 of a cookie cake eaten, okay? I think this next chunk makes it make more sense. How many cookie cakes have we eaten? 1 and 1/3. Do you guys see that? I think that visually makes more sense. We've eaten an entire cookie cake and 1/3 of another, all right? So the mixed fraction that they're looking at is 1 and 1/3. Can I make that make sense to anybody more than it? Is anybody struggling with that? So you just look at each individual to come up with the denominator and then count them like normal. So we had 4 shaded, so we have 4/3. And then step back and say, okay, if those shadeds are what we've eaten 1 whole cookie cake and 1/3 of the other there. Okay? And we don't know yet, but in like 10 minutes or 5 minutes, we're going to learn how to go back and forth. And some of you guys already probably know how to go from a mixed number to improper and so forth. Help me out with this one. We're going to do the exact same thing. Let's figure out our denominator first. Even though we're kind of looking at both triangles, we're going to focus on how many sections are just in one triangle. 4. So our denominator is going to be 4. Of those 4 little triangles, though, how many total are shaded? 5, right? Because we have 1, 2, 3, 4, and then that 5th tip. So 5/4. If for some reason we have a triangular cookie cake, I don't know why we would, how much cookie cake have we eaten? We've eaten 1 and then 1/4 of the other. Is that making sense? So nothing too scary? Yes, good. That's a good start to fractions, guys. In my math lab, we'll just do the same thing. They will give you a picture. They'll ask, what's your improper fraction? That will be that. And they'll ask, what is your mixed number? And that will be that. So do we need to label these? Improp frac, and then this is mixed number. Just so you know which one's which, I don't know. You might not need that. Any questions? We're good? Okay. So the bottom now is, can we do it on a number line? And basically the number line, we're just going to make it exactly like those drawings that we did before on the bottom of the front page. However many slices we need, we're going to count over that many and make it a whole, okay? So let's make 0 right here. Let's make them obvious. There's 0. And how many slices do we need? 7. So what we're going to do is we're going to go count like the chunks, right? We're going to count 1, 2, 3, 4, 5, 6, 7, and make a bold line there and make that 1. So that is 1 whole, okay? So we're going to go 1, 2, 3, 4, 5, 6, 7. And that's going to be 1. That's 1 whole rectangle, right? And we already have it divided into 7 chunks. So where do we need to go to represent 5/7 of that?
And count 5.
Count 5 over, okay? So basically what we did right here, guys, is we drew our entire rectangle, and it was already cut into 7 sections. So now we have to shade 5 sections. You're not really shading, you're just going to go count over. 1, 2, 3, 4, 5. Right there is 5/7. Does that make sense that you're 2 away from being a whole? Yeah, if there's 7 slices and you've eaten 5 of them, how many remain? 2. If you ate 2 more, you ate the whole cookie cake. Do you guys see what we did there? So count however many the denominator is to get your whole rectangle, and then count over however many your numerator is to mark the actual spot. And this might be a little bit harder than even what my math lab is, because my math lab, you might just be dragging it. You don't have to actually mark the hole and all that kind of thing. Okay, so this has 3. Again, make an obvious 0. This one gets kind of tight because the slices aren't very big. So we need to count over 3. 1, 2, 3. And there's my 1 hole. Is that okay? And then of this hole, how many do I have to shade? 2 of them. So I'm just going to count over 2. 1, 2. So there's 2/3. Is that okay? You guys are looking bored. Is that because we're getting it and I'm just over explaining? Am I over explaining? It's just fractions, okay? It's just like, we're just going to have this look for the next 3 weeks because we're dealing with fractions. All right, same thing here, guys. Let's make an obvious 0. But since we have 6 as our denominator, we're going to count over 6 slices. 1, 2, 3, 4, 5, 6, and make our whole there. That's 1. So there's our whole cookie cake, but now we're going to eat 4 slices. So we're going to count over 4. 1, 2, 3, 4. So this is how many you count over. How many total? And then how many you count. All right. If there's no questions there, I'm going to go ahead and move on to the next page. Are we okay? I'm overkilling that probably. So now they just got to make it hard on us, but keep the same kind of mindset, okay? Whatever the denominator is how much a whole is. So we got to count that many, but we might have to go past 1, because notice 8/3 is more than 1. So we might have to count over a little bit, okay? So make your obvious 0. And again, this is how many slices we have to have in our 1 whole cookie cake. So we're going to count over 1, 2, 3. And we're going to keep doing that a couple times. 1, 2, 3. 1, 2, 3. I had to keep doing it because I ate more than 1 cookie cake, okay? So here's 1 cookie cake, here's 2 cookie cakes, here's 3 cookie cakes. Keep doing it if you want to do the whole number line. You might ask, Molly, why did you know to stop at 3? Because I couldn't keep going, right? So keep doing as much as you need to do. And at this point, just start at 0 and count 8 over, okay? So we're going to just go 1, 2, 3 is 1 whole cookie cake. 4, 5, 6 is another cookie cake. 7, 8. 8/3 was 1/3 away from eating 3 cookie cakes. But I just counted 1, 2, 3, 4, 5, 6, 7, 8, just like we did before. Is that all right, guys? So the denominators are still matching how many you need to count over to have a whole. You just might have to go past 1, 2. All right, B, how many are we going to count over to make a whole cookie cake? 4. So we're going to have 0, and we're going to count 1, 2, 3, 4, and make a 1. But from there, we're going to count 4 more. 1, 2, 3, 4 to make a 2, and I have to stop because I have no more room, okay? And then from there, you just go back to 0 and count 5 over. So we're just going to go 1, 2, 3, 4, 5. Here he is. It's just 1/4 past 1. So I ate a whole cookie cake and then 1 more slice. So I'm just counting 1, 2, 3, 4, 5. This one's kind of interesting. Don't we know what 7 over 7 reduces to? 1. So what you're going to notice is that you're going to make this division of 7, and then you're going to count over 7, and you're just going to land on 1, okay? So we have 0 here, but our denominator says how many slices we need. So we have 1, 2, 3, 4, 5, 6, 7. So there's our 1 whole, right? But how many do we need shaded? All 7. So I'm going to put my dot there as well, and that's 7 over 7. So it's kind of making you visually see how, like, any number over itself reduces, right? If you have 8 slices in a cookie cake and you eat all 8, you ate a whole cookie cake, okay? So 7 over 7 is the same as 1. You guys are going to love the second half of this page. I think half of you are probably already done with it and moving on to the back. The second part is just making sure you remember all the reduction rules, okay? Anytime you take a number divided by itself, it's just 1. Anytime you take a 0 divided by any number, it's 0. Any number divided by 1 is the number, but anytime you divide by 0, womp, 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 you just blew up the whole world, is what I say. It's called undefined, all right? So real quick, if you already did it, just make sure your answers match mine. What's 9 over 9? 1. What's negative 6 over negative 6? 1. What's 0 over negative 1? 0. What's 4 over 1? What's negative 13 over 0? Yeah, didn't trip you guys up. I love it. And then negative 13 over 1? Negative 13. Remember those rules, right? A negative divided by a positive, all that stuff. Do you just want that to be on your test?
Yeah.
That's your fraction test. Wouldn't that be great? Yeah, I could do that. That test isn't bad at all. All right, so this is the only part where we kind of have to do computation, like actual math. It's saying, okay, if I give you a mixed number, so a whole part and a fraction part, can you change it to an improper fraction and vice versa, okay? So they have steps, so let's read the steps and make sure we feel comfortable with them. It says, first, multiply the denominator of the fraction by the whole number. So what you're going to do is you're going to take the denominator times the whole number, and then you're going to add the numerator to that, and that's going to be your new numerator, okay? And then your denominator stays your denominator. So this is kind of, some of you guys might have had teachers that did this. You do times plus, like that. So you're going to do 7 times 5 first, and I'll show you why this works, okay? 7 times 5 is what? 35, and then add 2 more, 37. And then what was our denominator the whole time? 7. We have 37 sevenths. I'll show you why this works, because I think so many of us know how to do it, and we just mimic it and do it, but we don't know why it makes sense. I'll show you on the board in a second. Do the same thing over here. We're going to take our denominator times our whole number. So what's 3 times 6? 18, but then add 2 more. 20. But what was our denominator the whole time? So you have 20 thirds. This one's going to get big, but that's okay. We can do it. You're going to take your denominator times your whole number. So what's 10 times 10? 100. You can just add those 2 zeros, right? Plus 9 more is 109. But what was our denominator all along? 10. We can do 5 times 4, which is 20. Plus 1 is 21. But what was our denominator all along? 5. Okay. Let's see. Let me know if our tape runs out. Why this works, let me show you right up here. I'm going to just do it with halves, okay? So say I have 2 1/2. Visually, what is that? It's 2 1/2 cookie cakes. Do you guys agree with that? So 2 whole cookie cakes in 1/2. How many total halves did I shave? 1, 2, 3, 4, 5 halves. And notice that math works. What's 2 times 2? 4. So basically when you do 2 times 2, you're counting the wholes, how many whole parts you have. And then when you add that numerator, you're just adding that fraction part to it. So we had 10 whole cookie cakes cut into 10 slices. So we had 100 slices. But then we had 9 slices left over. So we had 109 slices. So that's why that math works the way it does. All right, last one, guys. This is just division, okay? How many times does the bottom number go into the top number? And your remainder is your new numerator, okay? So how many times does 5 go into 9? Once, but what's your remainder? 4. So we have 4/5. That means 9/5 would be equivalent to 1 whole cookie cake and 4/5 of another. So we did 9 divided by 5 was 1. And then that's your numerator for your fraction, okay? So that's your whole number part. So your quotient, how many times it goes into it's your whole number, so that's 1. And then it didn't go in perfectly, so your remainder is your numerator, okay? So 1 4/5. So we'll just do the same thing over here. How many times does 9 go into 23? 2 times. What's 2 times 9? 18, okay? So our remainder ends up being 5, okay? So how many whole cookie cakes did we have? 2, but what fraction of the other cookie did we have left? 5, and your denominator, guys, is always your denominator. You never change denominator, so it's still going to be 5/9. Is that okay? This one's kind of a trick question. Why? What happens when you do 48 divided by 4, guys? It goes in evenly, right? 4 goes into 4 1 time. And then 4 goes in 8 2 times. So really, your mixed number is just 12. And actually, we got to change that, right? Each has a mixed number. That needs to be changed. We already did the improper fraction right above. All right, last one, kind of tricky. Why? Because we're not necessarily that comfortable with 13's times tables. 62 divided by 13. I'm doing 13 times 2 up here. What's that, 26? 13 times 3, 39. 13 times 4, 52, right? So that's going to be my winner there. So how many times did 13 go into 62? 4 times, with a remainder of... And 10's kind of big, but it's still smaller than our denominator, so that's okay. So our whole number is going to be 4. Our fraction is going to be 10/13.